We continue section 1.6, exploring other types of equations other than linear and quadratic. In the next example, we have an equation that includes a special pattern. We certainly can solve this equation by distributing and converting it into a quadratic written in standard form, but we're actually going to take a shortcut and also develop the skill of recognizing patterns in doing so. We have 3 times the quantity x plus 1 that is being squared, plus 13 times the same quantity x plus 1, plus 4 is equal to 0. Because we see the binomial x plus 1 occurring several places, we're going to give it a name. We're going to let the letter u stand for that quantity x plus 1. We'll give it a bit of a nickname. Now we can rewrite the original equation as 3 times u squared plus 13 times u plus 4 is equal to 0. Notice that this is clearly a quadratic equation, and it also happens to be a factorable trinomial on the left. Let's factor as 3 times u, and then a u in the second set of parentheses. And let's factor the positive 4 as 4 and 1 with addition in both binomials. A quick check will verify that this is the correct way to factor. Using the zero product rule, we find that either 3u plus 1 must be 0 or that u plus 4 must be 0. That means that 3u must equal negative 1 or u must equal negative 1/3 or u must equal negative 4. Typically, we would be finished with the problem. However, we did use a nickname for the quantity that we were trying to solve in the first place. We do know that the two values for u are negative 1/3 and negative 4, but let's see how this determines what the values of x would need to be. Let's go back to the nickname of u as a substitute for the quantity x plus 1. So if we go back and say that x plus 1, which is what u stands for, must equal negative 1/3, or that x plus 1 must equal negative 4, we've made the connection between the values of u and the values of x plus 1. Now we can solve for x by subtracting 1 from both sides. So either x is equal to negative 1/3 minus 1, or x is equal to negative 5. We can write the first solution as x equals negative 4/3. So the two solutions for x are either x is negative 4/3 or x is equal